this video, we're talking about addition and subtraction of rational expressions. Keep in mind that a rational expression is exactly the same thing as a fraction, so it has a fraction with a numerator and denominator. But either the numerator and or the denominator is a polynomial instead of just a whole number. So in the past, we've dealt with regular fractions of whole numbers like 1/3 or 2/5, where the numerator and the denominator were whole numbers. Now we're dealing with fractions where either the numerator and or the denominator is a polynomial, not just a whole number. So what do we do in that case if we want to add or subtract expressions like that? Well, in this first example, we have a over 3 plus b over 3. So just like with regular fractions, the first thing we need to do is find a common denominator. In this case, we already have one. The denominator of both fractions is 3. So we can combine the fractions. We just can't combine a and b because they're not like terms. So the result then is just a plus b over 3. Because a and b are not like terms, we just can't simplify any further, but that'll be our answer. What about something like 3 over 4 plus 2 over b? Well, same thing here. We need a common denominator. One denominator is 4, the other one is b. So we're going to multiply this first fraction by b over b, and we're going to multiply the second fraction by 4 over 4, because that'll give us a denominator of 4b in both fractions. So the result then is 3b over 4b plus 8 over 4b. Now we have a common denominator and we can combine the fractions into one. So we'll get 3b plus 8 all over 4b. Let's look at this example here. We have 5x plus 7 over 5a squared x minus 3x minus 2 over 5a squared x. So again, we're looking for a common denominator, and luckily we already have one. The denominator of both fractions is 5a squared x, so we can go ahead and combine them directly. Here's where we have to be really careful. This is the first problem where we've had subtraction. Well, when we combine the fractions, we know the denominator is going to be 5a squared x, but the numerator, we take the 5x plus 7, and then we have subtraction. This subtraction is not just minus 3x. The subtraction applies to the 3x and the negative 2. So we have to put a minus sign and then in parentheses put 3x minus 2 so that we make sure we apply the negative sign to both terms of this second fraction. So we've got that, and then we have 5a squared x. Now we'll go ahead and distribute the negative sign across the quantity 3x minus 2. We'll get 5x plus 7 minus 3x. Negative times a negative 2 is a positive 2, so minus a negative 2 is a plus 2. And then in our denominator, 5a squared x. Now we just need to make sure that we can't combine like terms. In this problem, we can actually. We have 5x minus 3x is going to be 2x. Remember, 5 of them minus 3 of them is 2 of them. So I have 2x, and we have whole numbers we can combine. Positive 7 and a positive 2 is a positive 9, so we get 2x plus 9 all over 5a squared x as our answer. Looking at the last problem here, we have m over c cubed plus 4 over c squared minus 6. The first thing we need to realize is that 6 is actually 6 over 1. Now we've got three fractions which we can deal with by finding common denominator. Our denominators are c cubed, c squared, and 1. So what's the least common multiple of c cubed, c squared, and 1? Well, it's going to be c cubed, because we can just multiply this second fraction by c over c, because in the denominator that'll give us c squared times c, which is c cubed. Here we'll multiply this by c cubed over c cubed, because 1 times c cubed will give us c cubed, and so now we'll have a denominator of c cubed for all three fractions. So writing this back out, we get m over c cubed plus 4c over c cubed minus 6c cubed over c cubed. And now we can go ahead and combine the fractions into one. So we'll get m plus 4c minus 6c cubed all over c cubed. And we don't have any like terms that we can combine because m is obviously going to be different than our terms involving c. And here we have c to the first power and c to the third power. And when we have addition or subtraction of these terms, the base and the power have to be the same. The bases are the same, they're both c, but the powers are different. This is c to the first power, this is c to the third power. So we can't combine any like terms, and that'll be our final answer. So that's how you deal with addition and subtraction of rational expressions.